Hello, and welcome to Summarize Science, where we break down complex research for you. Today, we're looking at a fascinating problem with AI that can both see images and understand language, known as multimodal large language models. You might think that if you give one of these AIs an image and a text prompt, it would use both equally to figure out an answer. However, these models have a text bias, meaning they often listen to the text prompt and largely ignore the visual evidence right in front of them. For a long time, the common belief was that this bias came from external factors, like the AI being trained on imbalanced data. But the researchers behind this paper proposed a radical new idea. The bias isn't from the data, it's built into the very architecture of the model. They hypothesized that the part of the AI trained on language is so dominant that it treats visual information like a foreign language it doesn't quite understand. As a result, it defaults to what it knows best, which is the text. To test this, the team looked under the hood of two popular open-source models, LLaVIA and Qwen. They focused on the attention mechanism, which is how the model decides which pieces of information are most important. They extracted the internal signals, or key vectors, that represent visual information and textual information during processing. And what they found is visually striking, as you can see in these charts. Each dot here represents a piece of information, with the blue dots being text and the red dots being parts of the image. As you can clearly see, the visual and text signals occupy completely separate clusters. They live in different neighborhoods inside the AI's brain, with almost no overlap. This separation persists across different layers of the model, showing just how fundamental the divide is. The researchers didn't just rely on pretty pictures, they crunched the numbers to prove it. This table quantifies the distance between those clusters, and the results are dramatic. The divergence between image and text signals is consistently orders of magnitude higher than the variation within the text or image groups themselves. So, let's recap the important points here. This study provides strong evidence that the text bias in these powerful AI models is not just a data problem, but a core architectural one. The way these models are built creates a fundamental misalignment between how they process visual and textual information. The visual signals are essentially out of distribution, causing the attention mechanism to systematically favor the more familiar text signals. The difference isn't small either. It's a massive, statistically significant gap. What this means for the future is that simply fine-tuning with more balanced data isn't going to be enough to fix the problem. This research shifts the focus for developers towards redesigning the internal architecture of these models. The goal will be to bridge this internal gap and create a more unified key space where text and vision can be compared and weighed more equally. Achieving this will be a critical step toward building more balanced and genuinely intelligent AI systems that can reason with all the information they're given.